homework web page, and it says PTOE scavenger hunt. Click this now. Who's already here? I know that though sometimes the computers are a little slow to come up. So the PTOE scavenger hunt, that's your warm up for today. And I'll put it up here until you guys get there. But basically, you're going to look on your periodic table that I gave you because there's this nice key on the top of it that gives you a legend. And it gives you a little bit of information up there. I'm going to give you guys 10 minutes. There are 20 of them, and it's going to help you kind of navigate the periodic table. Where's the person next to you? Okay. You guys will write this in your warm-ups. Write it in your warm-ups so you always do it. I have mine. Alright, you have 10 minutes now, okay? Let's go. Work with the person next to you. Talk to them.
What is the name of the found it. Wait. Average mass? 39. I think 6,000. Now? Calculator was 112, 65.
Alright, finish the last one you're on. Alright, so I'm going to call out names. just to randomize this a bit, so I got a lot of people who would love to participate, and I need some other people involved. So just, I'm gonna say the number, and you guys just tell me what you guys think. This is at least a good idea to keep looking at periodic tables, so you can find where things are, because you can probably hunt for, you can probably hunt for bismuth for a day, right? It's sometimes hard to find these things, so it's nice to look at this more regularly. All right, Harshita, tell me about number 14, atomic number 14 on the periodic table.
Silicon.
Right, Si, silicon. How do you say silicon in Spanish? C. Si. Come on, guys. Okay. Moving on. I don't have a joke for every one of them, but I start to get it. Okay. Alex, number 2, California. CF. Can you guys guess where that was discovered? California. Okay. How many protons are in bismuth? Will Evans. 83, right. So I'm going to pass around these while I'm thinking of it. Bismuth is my absolute favorite element because it's beautiful. This one I'm keeping in the bag because one of my students they melted down bismuth for me and they made it, so I don't take that out only because it's particulated. And then I'll start this one actually over here. And then when I put that surveying this one, but it's beautiful.
Why does it do that?
It crystallizes in a very funny shape, and the crystalline structure is actually like a staircase. And it also has about 5 different colors to it because every charge it takes on has a different color. And so as Amory continues to do knowledge, she's going to keep passing for me. But it takes on those colors because it can form up to 5 charges. It's also, you guys have heard biz before. Pepto-bismol, right? That has bismuth in it, which actually soothes your stomach, but at a certain dose, it's toxic, which is why chemists make our medicine so that they're not going to kill us. Most of them, anyway. Okay. All right, we're going to keep going while you pass it around. Back with me. Back with me. Anushka, 4, argon.
Argon is A.
Right, so it's in group. Right, 8A. Group 8A is the simple gas group. Josh, what's going to have higher mass, cadmium or zinc? Right, so you're seeing that organization of periodic table goes from heavy or light things all the way down to heavy things. Good. Hunter, atomic mass of carbon.
12.1.
Right, so you're seeing the atomic masses on your periodic table, the lower number there. Good. Olivia, element series 57 to 71. Right, the lanthanides. And what's weird is look on the periodic table on the wall over here. You see the light blue and the green? Okay, so that entire row fits in there. The reason they do that is because they don't want the periodic table to be that long. They just remove that section so it's not as long as the wall. It's just going to fit on a piece of paper when they print it. It's just legit for just printing purposes. I think it's a shame, but that's why they put that there. It's because it's nice and pretty that way. Okay. Allison, number 8. Gold, right? What's its symbol? AU, right? So that's going to be not the same first letter. The lowest atomic mass, Aishi. Number 9. Right, hydrogen, what's its mass? Right, 1.00. What's up, Will?
How come that one has LU and LR?
So if you go ahead and click on the link on the very bottom of this document. Do you see that the newest periodic table? Thanks for asking that now. So this one on the wall was updated last year. The one I've printed out or I've clicked for you or inserted as a link for you is the newest. So what happened was they atom smashed, right? They threw out 2 different atoms together and they smushed their nuclei together under really high pressure and really high velocities. They have an underground like racetrack for atoms. They fling them around and they smash them together. And then when the nuclei fuse, they'll actually add 1 or 2 different protons to their nuclei. So the one over here, like livermorium 116, they smash together 2 atoms. So whenever they do that, they're like, hey, we made a new element. Woohoo! We made atomic number 114 and 116, 117. And the people who were involved with that process, they're in charge of naming them or proposing the names. It takes like a year for an element to get named. Okay? So they propose all these names, and then it's like, I vote for this one, I vote for this one, and then they come up with the name of it. It's nothing fancy. It's just they vote. And so now we have all these new names like fluorbium, livermorium, and so forth. Okay? Say again?
So I can call it William.
Yeah, so most people want to try to name something after themselves. Like you'll notice some start to see some names appear soon. Einstein, yeah. All right. Yeah, they made it in Tennessee. That's why it's Tennessee me. Gosh, yeah. If you dang it, americium is what it said.
There's one called aluminum.
In Britain, they called it aluminium, but it's aluminum in America.
Oh, it's just aluminum.
Yeah. There's also someone called oxygen. You guys use that a lot. Okay. Moving on. Amory, help me out with 10. Yeah, first element with atomic mass greater than 100. Ru, right? Rutherfordium. There's not a D in it, but it's named after Mr. Rutherford. Alicia, tell me about first basic metal, and I might have to help you here. Beryllium, right? The word basic, write this down for yourself. The word basic means, the word alkaline means basic. So where are the alkaline metals? They're in the first or second group? Second group, right? Or second group. Back with me, we're almost done. True or false? What'd you say, Madeline? False, right? Because we definitely can see they're not in the same group because groups run which way on the periodic table? Which way? Down, up and down. Groups are up and down. These were across, they were on a period. Heaviest alkali metal, Garrett? Francium, right? And that's at the lowest left-hand corner. Nathan, what about protons in magnesium? 12. And then, which is not a non-metal? Amina's not here. Gwen? No, oxygen, sulfur, and nitrogen are definitely non-metals.
Okay.
Those are all gases, non-metals. It's the other one. Silicon, right? Silicon is actually a metal void. It's a flexible, it's a kind of a blended metal, non-metal feature. Do you have a question?
Is that one just in a bag because it's broken up into pieces?
Alexia, tell me about, W. Tungsten, right? So this guy named Wolfram was actually in charge of helping discover that one. Okay. How about Parker, 17? Palladium, good. PD. Acetine is on is in which group? Ethan. Halogen group, which is 7A, good. BA stands for what, Emily? Ooh, so let me help her out. Barium. BA is barium. Good. And then everybody, what symbols or what letters not used? Okay, so it's a fight, right? So Q used to be on it because they had like quartium and all these are UUT, so forth. So Q used to be there, but now it's off. So J is the one that's not on it, like legit, but Q used to be on it, now it's not. So if you put J or Q, you're good. Okay. So can you spell your name with the periodic table symbols? Who can't? Who can't spell their name? You should be able to. Okay, Josh, I know. I'm feeling you. I can't either. You should be able to. Thanks. Do you see it?
No, I was going to hand it to you. Oh, there's a W.
Alright guys, and let's switch modes back. Go back to the homework webpage. Go back to the homework webpage. I'm going to explain this one time, and then I think you guys will be good to be set free, okay? You ready? If there's that baggie around, hold up the baggie. Okay, I'll give you a second. Okay. So, atomic model assignment project guidelines. So if I assign a project, I try to assign it very early in the unit, so then you have the entire unit to work on it and make progress and collaborate. So this one is going to be due in about 2 weeks. I don't have the date on hand, but it's for our next test. Okay. So let's click here first, and then I'll tell you what your steps are for today. So I'm going to have you guys watch the video with me first up here because it doesn't work on everybody's computers because it's a flash-driven thing. So we'll watch this first atomic model quick video, and then you guys can take the quiz there with a partner at your seat. After that, I have these atomic model cutouts, and you guys are just going to arrange them in chronological order so that you can see where we started way back in the day to where we're ending, so that you can see the overall evolution of our thought process of understanding how the atom looks. Because, you know, we can't see it still. We legit can't see it. We have to use a lot of light and other things to bounce back information to us, but we still can't see the atom. It's so, so tiny, okay? After that, the graphic organizer, I have printed that for you. You picked that up just a minute ago. It looks like this. Okay, it's a front and back. Make sure you have that. Alright, so on the front and back, this still walks you through the evolution of the model that we call the atom. And this will give you some fill in the blank spots. I have two sets of notes that you can use to fill in the blanks here. but you will not find everything on there. You will have to Google some and kind of look between the lines to start to fill in the blanks that are provided here. But I thought this would be a great study guide at the end of things because you have both. You have the front. Does everybody have one of these? Okay, you have the front and the back. That's going to be from, the 400 BC all the way up to present day. So when you click on the Miss Inlow's PP or PowerPoint or the Evolution of the Atomic Model PDF, those are both really good resources. But if you go down to the bottom of the screen, there's a lot more details and something that will help you there. Okay, so let's start with that, and then I'll work through what the project guidelines are. Because obviously you guys can read it, but I want you to walk through pieces of it. So let's watch this first together. And you guys, of course, can always find this on your own, but it's right here. It says Atomic Model. And let me make sure Pandora's off for a second. Oh, Pandora. I'm not. All right. So, nope. Pandora just started back up. So let me just, it's embarrassing. Is it playing or is it not? It's not. That was not this. Okay. All right, you guys ready? Play the movie. It is small, but work with me. I can't.
Ooh, a present. Dear Tim and Moby, how do we know what atoms look like if we can't see them? From Darren. The atoms are small, real small, too small to be seen. Still, scientists can do experiments that tell them things about what makes up an atom. Right you are, my robot pal. You can't see what's inside the box, but shaking it can give you clues as to what's inside. It's the same with atoms. Using indirect means, scientists have been able to construct different models of the atom. This atomic model has taken years and years to build, and people still tweak it now and then, hopefully making it more and more accurate. Let's take a trip through time. At the beginning of the 19th century, Englishman John Dalton built an atomic model called the atomic theory of matter. Dalton's model was really just a set of ideas. According to his theory, each type of matter is made of only one type of atom. For example, gold atoms make gold, iron atoms make iron, and so on. These atoms were way too small to see. So far, so good. About 100 years after Dalton, J.J. Thomson discovered the electron. Thomson used a vacuum tube with metal plates at both ends and an electrical source for his experiment. He found that a beam would form between the two plates, the cathode and the anode. Putting a magnet near the beam caused it to bend, which meant that the particles of the beam were electrically charged. Thomson discovered that the cathode rays were made of negatively charged particles called electrons. Because matter is mostly neutral, with no net charge, atoms must contain both positive and negative charges that cancel each other out. Thomson stated that negatively charged electrons must be stuck all throughout a positive mass. Think of it like the atom is cookie dough and the electrons are chocolate chips. The discovery of electrons was a big deal, but it left some questions to be answered. What were the positive particles holding those electrons in place? In 1909, Ernest Rutherford and his team set out to answer some of those questions. They beamed positively charged alpha particles at a sheet of really thin gold foil. Because so many particles could pass right through the thin gold foil, Rutherford hypothesized that the gold atoms must mostly be made of empty space. But some of the particles did bounce off, so Rutherford revised his hypothesis to say that a gold atom must have some very small positively charged mass. He named this mass the nucleus. He called the positively charged nucleus particles protons and said that the electrons were scattered in empty space around the nucleus. James Chadwick, a student of Rutherford's, found new particles in the nucleus that weren't affected by an electric field at all. Alpha particles in the experiment had knocked them loose. Chadwick called these uncharged particles neutrons. Also in the early 20th century, scientists discovered that electrons are arranged in energy levels. The lower energy levels are closer to the nucleus and can hold just a few electrons. The higher energy levels are farther away and can hold more electrons. Electrons are so small and quick that their energy levels are not neat planet-like orbits around the nucleus. Instead, they exist in a region called the electron cloud. The atomic model is constantly evolving as scientists discover more and more about what makes the universe tick. Oh, okay. Go ahead and open it. Hey, it's an atomic model. Well, you have to put it together.
All right, hold on. And
That's not right.
we have to wait to take the quiz together. Okay, and you guys, if you guys can access it, you guys can take the quiz with a partner next to you. If you go to Chrome, it should work. Or Mozilla, but Chrome should be your best bet. So open that back up, and then I'll take about 10 seconds. Okay. that face of the person next to you. Did you guys see where it was accessible by?
Turn up my brightness.
Atomic history, or atomic model.
Yeah, I already got it.
You guys just take the quick right now. You don't have to write anything down.
Looks funny. Let me check the one out. Oh, the lighter popped up. Mine was great popped up. Wait. About how big is that? Correct. I know, I got that correct. We're getting it right here.
Guys, you're not going to work together anymore. Okay?
Are you supposed to write it down?
No.
No?
Just take it. Just take it visually. Okay?
Go to write again.
Once you guys are done, you're going to start with these, okay? So this is your notes. So I'm going to give you guys about 20 minutes to knock this out. That means go to the next part of the Google Doc.
Yeah, so. Where did you get that?
Alright guys, I think you've everybody's had time to finish that quiz. And can you turn back here just for a moment? Alright, so I skipped this for just a minute, just kind of let everybody finish that little ding. Okay, so for about, I'd say 25 minutes or so, you guys will be probably working with one person right now. So one person can have the PDF up, one person can have my notes up, and then of course you guys have the World Wide Web. At the end, I will go over pieces of this to make sure that you guys got the fill in blanks right. But I need you to kind of read between the lines for what words we're pulling from that information. Before you tackle that yet, though, you guys see these baggies? Right here, I can see some people. I'm behind you, sorry. But I have them spread out. If you guys will pull one person, so the person you're next to, or if you have another partner, that's fine. Come back here and put these in chronological order. And if you'd like, you can take your notes back here because there's just more space. Okay? Let's go. Yeah. Person next to you works fine, or you can have another partner. You have a natural partner. Just show me when you're done, guys. When you're done. Amina's buddy? Absentee buddy. Amina's.
Oh, yeah.